make sure you're focused on learning today about what's happening. Today we're looking at 9.1, Notes Day 1, transformations, specifically translations. Those are two different keywords. Transformations, a general overall thing about translation, reflection, rotation, glide reflection. Okay, they're general. Okay, it's a general for all these. Isometric transformations is another category of transformations, and these are the ones we're learning about. An isometric transformation's rigid, which means when I move to my left, you'll see me move to the right. I'm the same person. I have just switched my position. We'd be in the same shape. If I move a shape around the plane, it stays in the same shape the entire time. Now, there are all sorts of transformations. If I take a piece of paper, this is the original, and if I move it around, it's isometric. But if I do this, it's a non-isometric transformation. I've transformed the paper by crumpling it up. It's a ball, right? And it's great if I want to sit around and shoot hoops in my basket all day, okay? But that's a type of transformation as well, okay? The transformations we're learning about are transformations that will extend our understanding of functions transformations. We're going to learn about parent functions as an Algebra 2 student, and you'll transform it around the axis, around the XY coordinate grid. And these are just basic things that you will work with it, but we're doing it in a safe environment, this ship moving around shapes, okay? I was gonna say shaping around moves, but you guys get it. So here's what we got. A transformation is a change in position, shape, or size of the figure. Pre-image, the original figure, before the transformation takes place, okay? Your pre-AP, you take a course before the AP course because you're getting ready for it. Your pre-calc, because you're taking a course before you take calc. Well, these are pre-images. It's the image before our transformation occurs on and puts our image in our final resting place, okay? Now, image, the resulting figure after the transformation. Isometry is, please put is in there, I'm sorry. You know, you pre-read these things and you pre-read them, and then when you finally read them and you're relaxed and you're drinking coffee, you go, yeah, I forgot that. There is? Good, all right. So it was just on this piece. Good, I caught it on that, yours, not on mine. A transformation where the pre-image and image are congruent. That means corresponding sides, corresponding angles. All this corresponding stuff we've been doing throughout the entire year, okay, lines up. Now, determine if the transformation is isometric. Remember, I can flip it like a pancake, all right, and it's still the same shape. It's an isometry, okay? If the size changes, it is non-isometric, which means it's a different shape and it's not isometric, okay? An isometry is a rigid transformation, okay? Those are synonymous. So look through, make a decision. Is it an isometric transformation or isn't it? Isometric transformations, same shape. So you guys go ahead and answer all four of those. Welcome back. How you doing? Feel better? Okay. Next week, Wednesday? Okay, I think maybe let's talk Tuesday, all right? And see how it is. Okay, now, some people are freezing going, oh, which one do I do? Keep in mind, I did this so you can see coming over. Woohoo, right? Pretty cool, right? Okay, so we know that that's going to stay the same shape as we go through. And yes, this isometry, size and shape are the same. Now, I am parroting back the definition of isometry when I answer this. Now, I've got some people going, yes, no, yes, maybe. Guys, use the words we need to learn and you learn them faster. Okay? Force yourself into that habit. Here, this is considered a dilation. When light hits your eyes, okay, your eye shrinks or expands, okay? Or if it dims, you know, it opens up so it allows more light in. Well, that's dilating, okay, whether open or closed. This is a dilation, when your transformation from pre-image to image gets bigger or smaller. So when we're doing this, not isometric or not an isometry, just similar. And they're similar shapes. So we have the idea of similarity coming from the previous chapter. Here, again, pre-image and image, pre-image to image. It shrunk, okay? It was a size change, it got smaller. Not isometric, excuse me, it's just similar. And the last one appears like it flipped, right? Like I'm flipping burgers, flipping pancakes, it's the same shape, it's just, you know, the other way. And that's a nice isometry, size, shape are the same, okay? Now I'm hoping you're starting to recognize, I go from one thing to another, I slide it around the XY axis, okay? Now, this arrow is a big deal as I'm going through here. This arrow right here is used between the pre-image and image to represent a transformation which maps, they call it mapping, okay, which maps a figure onto its image. So if I slide this image, well, maybe I should bring this back here. I already got that in there. If I'm sliding this image over, but remember I've flipped this to be, and it's left and right. So if I take this shape and slide it over, that's a transformation, but I can flip it, and that's also an isometric transformation because you can see that I've done that, okay? And it is that JKQ maps onto J prime, K prime, Q prime, and people are like, well, how do you know which points line up? When we first do this, when we have A prime or a double prime, okay, with the figure, and is this telling you, the reader of the diagram, that a transformation is taking place. And this is the pre-image. This one's pre-image, and this is image. Okay, the change took place, and now you have an image. Okay, think about it as you go through and you make a decision. You're going to behave this way because you have an image to uphold. Okay, so that's your image that, you know, people see every day. Well, you had a pre-image and you're making a change. So now that's your image. Okay, so I want you to think about it that way. So every time we talk about these rules, we're going to go from pre-image to image, but we're also going to learn about going from image back to pre-image, and we'll talk about that when it comes. Okay. Now, the prime notation is sometimes used to identify images points as a incongruence and similar figures. Corresponding points of the pre-image and image are listed in the same order. Order matters. Just like congruence, just like similarity, corresponding angles are congruent in isometric transformations. Okay. In the diagram, E prime, F prime, G prime, H prime is an image of E, F, G, and H. Oh, thank you, dear. Okay. So here's the deal. Which are the images of angle F and angle H? Well, angle F goes to F prime. Angle H goes to H prime. Do you see that correspondence? And it was really nice because we had primes, okay? They don't flip-flop with the primes. So angle F, or angle F prime, is the image of angle F. Please notice how we said that, because angle F is the pre-image of angle F prime. But they asked, what is the images of angle F? Angle F prime is the image of angle F, and you guys find the other one. Go ahead. Answer it the same flavor in order. There you go, Zacchaeus. So hopefully we have angle H prime is image of angle H. You doing okay with that? Any questions about corresponding angles, about the primes or anything? Bobbleheads are good today. You guys can talk, it's fine. You guys will be on the video and people go, who's that person talking in the background? Okay. Tom's me. Okay, in the diagram, triangle NID goes to triangle SUP. Now, here's the thing. I said that we'd have primes, but now we're going beyond primes. So corresponding points are in the correct order. So this is really, I said goes to or maps to. So N and S are corresponding. I and U are corresponding. D and P are corresponding. So answering in 3 the way we did in 2. What are the images of angle I? Well, angle I and U So when I go angle U, well, we should, angle U is the image of angle I as I go through. Angle U is the image of angle I if we want to order it and answer it the way we did in the first one. It's not going to be that structured, but I wanted to make it as simple as just module putting things in. Yeah, kiddo. I like the primary, but the pre-image, this is the pre-image because that's the one we started with because it's going to the other. It's going to the image, and we finally end at the image. So SUP, S-U-P, is the image triangle. Okay, and that's why I was able to say, you know, with this, what are the images of angle I and D? Well, U is in SUP, S-U-P, okay, and that's my final triangle. Okay, so angle U is the image of angle I, which angle I is part of the pre-image triangle. Okay. As we're going through, angle P is the image of angle D. Any other questions? Are we doing okay? Now, have you noticed that today is really just a lot of vocabulary, property stuff? It's not really hard math. And if you just keep in mind, pre-image is the starting spot. Image is the final resting spot. Okay. What are the pairs of corresponding sides in B? Pairs of corresponding sides. Let's talk about those pairs. EF and E prime F prime. Okay. Well, I got EF and E prime F prime. And all I'm doing, I'm going to tell you the secret. People are like, well, geez, how's you do that? I went EF. Now the next one I'm going to go FG, and the next one I'm going to go GH, and then I'm going to go EH in that order. And they're primes, so they're nice. Once you decide which one you're going to do, the other one had primes on it. Order matters. Go ahead and do the other three. Go ahead, do the other three. Your order of how you do the other three and my order are going to be different probably, but the pre-image stuff is all over here. The things that aren't primed are on this side. Yeah. Yep. Yeah, and really what it comes down to on this one, yeah, but they ask in this problem of H, so that's why we did H there instead of E. But if it was open, then yes. Okay, does that make sense? Sorry, that one for some reason doesn't come up. Got to fix that later. Are you doing okay? Feeling good? Now, the next thing is we're going to do it without the primes. Order matters, right? So, NI to SU, ID to UP, ND to SP as I go so I can catch them all. This is just like when we did congruence, lining up congruent angles, or similarity, lining up congruent angles. Okay. And I'm not sure why I went DN and PS, but if you went ND and SP, you're fine. Order matters though, so keep it in order. Okay, are there any questions about the order matters on these? Okay, now when you slide, that's a translation. A geometric figure, the size, shape, and orientation stays the same. Okay, when you slide or translate a geometric figure, the size, shape, and orientation stay the same. Now, key concept idea is a translation. We talked about it. We got isometric movements is one's a translation. The other three we're going to learn about over successive days. Okay. It's all about corresponding points and sides, and we're going to learn about a translation rule next. Okay, so we got that translation rule up here, and look at it. I've got the translation rule. Matter of fact, if you're going to put something in your notes, put it in your notes. Put in note card. Okay. Now, translation rule describes a translation in the coordinate plane. I'm going to go, and when I do this, or notation's important. I take my pre-image and I expect it. If you give me a translation rule, I expect the pre-image represented by XY. And then I expect the change represented by, you're going to have a horizontal and I have a vertical. Well, think, X is left to right and it's a horizontal change. Y is up and down. It'll be a horizontal change. If I move X to the right, I'm just adding whatever I'm moving. So if I move to the right 2, I'm going to add 2. If I move to the left 8, I'm going to subtract 8. If I move up or down, I'm going to do that to the y value. And so if I go up, I'm going to add to the y. If I go down, I'm going to subtract from the y. Okay, so we need to know those connections. Now, with that, here it is. I have an original shape, and I want you guys to graph PQR 2, 1, 3, 3, negative 1, 3. Go ahead and graph it on the axis. Graph 2, 1, 3, 3, and 1, 3 on your axis. 2, 1, 3, 3, and 1, 3. Because you need those graphed. I want to show you a couple ways of doing this. Okay. I'm going to show you the rule and how to deal with the rule. And I also want to show you how to deal with stuff on the axis because it goes pretty quick if you get it. Now here's the deal. I'm going to subtract 2 from every x value. I'm going to tell you the truth. It goes faster if you stay with the same variable and just keep subtracting the same thing, because then you won't get confused and it's a little bit more efficient with your time. So I'm going to take 2. I'm going to take this 2. I'm going to get a little cursor here so people know what I'm doing. I'm going to take that 2 and subtract 2 from it. What's 2 minus 2? 0. 3 minus 2, 1. Negative 1 minus 2, negative 3. So I should be getting those, and I'm going to do the same thing on the other side. 1 minus 5, negative 4. 3 minus 5, negative 2. 3 minus 5, negative 2. And that allows me to work faster when I'm working with a group of points. Now, on the test itself and on a quiz, I will expect you to be able to read points from the graph correctly. Okay. So you got to be really good at that. And then after you line it up, you're going to apply the rule just the way I did. Because on the test, it's obvious if you're right or not if I have specific points. If I do it on a graph, it makes it tougher because you didn't bubble really great or your drawing wasn't perfect. Well, I'm going to give you drawings like I am in C&D so you can make adjustments. I'll have 2 pictures on there and you'll be able to tell me what's going on. But in these I want to practice, and here's what this looks like on the graph. This is pretty cool. When you're doing this, instead of trying to redo these, I went 2 left, that's what that is, and 5 down. 2 left, 1, 2, 3, 4, 5 down. This is my R prime. Okay? I go 2 left, 5 down, that's Q prime. And 2 left, 5 down, that's P prime. That's pretty fast for me to regraph because I'm not just looking at my points, I'm just applying the same rule to every one of the vertices. Okay, so my final resting position should be right about there. I'm going to get rid of those so you guys can see where it went. Okay, so I want you guys to do the whole kit and caboodle, everything in the problem in B. Graph the original, give me the points, and slide based on the rule I gave you. Go ahead. Okay, so here's the story, Morning Glory. We are going to add 1 to all the x's, subtract 4 from all the y's. So A is going to be add 1 to negative 2, which is negative 1, and subtract 4, so it's negative 2. Negative 1, negative 2. Here, I'm going to add 1, and then I'm going to subtract 4. So I've got 2, negative 3. And here I got 1, negative 5. Now, when I make that change, again, I'm just going to apply that rule from A. I'm going to add 1, move over to the right, and go down 4, so I get there. I'm going to add 1 to B. I'm going to go down 4. I'm going to add 1 to C, and I'm going to go down 4. So at that final step, I'm going to be right there. Now, C goes a little faster. because we're already given the original problem. Give it a try. Go. Do C and D. Okay. Turn off the video. Do C and D. Okay. I'm going to subtract 1 from all the x's, add 4 to all the y's, and that's what I'm doing. How are you guys doing? Okay. Feeling good? Got thumbs up? Okay. Now, when I do this, I'm going to subtract 1 and add 4. Subtract 1, add 4. Subtract 1, add 4. So when I do this, I'm going 1, 2, 3. I don't know why I'm doing it that way. I'm going to subtract 1 and add 4. So that's my new b. And I'm going to subtract 1 and add 4. And I'm going to subtract 1 and add 4. And that's where everything moves to, and it's right there. Okay? Now, that last one, hopefully that went really quick. And we're right there. Are there any questions? Okay, now, pay attention to the rule. The rule, don't drool on this one, okay? Some rules do drool, but this one doesn't, okay? When you're doing these, pay attention. If I'm adding and I'm on the x, it's to the right. If I'm subtracting on the x, it's to the left. And by adding for the y, it's up. When I'm subtracting for the y, it's down, okay? So keep that in mind, please. Now, this next thing, a move to the right is just getting that down, okay? And I got E and F as, hey, are we getting it? So let's check those out. You guys go ahead and do it and get her done. But now, what am I having you do? I'm having you identify the pre-image and then the image. Which one's the pre-image? The one with primes or one without? If I got people without, I've got some hints. Let's check out the hints. Check the arrow, holy cow. Check the arrow, let's fix that. Check the arrowhead here. It's going from XY to this one, and everything on this side's gotta be pre-image. So M-A-T-H, isn't that cool? Math? Okay, all right. To M prime, A prime, T prime, H prime. So we're going from the pre-image to the image. So the image here is the primes. So you guys are going to go from the pre-image to the image, okay? And that's what we're going to be doing. And this is, that you guys have that point in there or not? No, you don't. Put this one in, and here it is. We are supposed to put 3, -4, okay? And people are like, yeah, but plus the -4. Because they told us what that would be, right? And now after I decide how they're going to ask me to move. And remember, anything to the right is add for x. Anything to the left is subtract. Anything up on y is add. Anything down on y is subtract. And remember, y is up and down, x is left and right. And they give us the information here. And now I just follow through on the rule. And I get it done. Go ahead, do F. Check with your row partner next to you, see what they did with F. Okay, I'm okay if you guys don't graph it. Don't, because it looks like it's really confusing me. Check your points, check what your rule was that you put up. How'd you do? You okay? How'd I do? Maybe I should ask you that one. We're doing all right? Now, here's the deal. I got a short, brief, like self-quiz on the next 4 questions on the next page. How are you doing? Are you getting it? Remember, it's all about you focusing on understanding this material every day so we're better in our futures. So you guys go ahead and do the self-quiz on this next page. I'll get the folks at home there. So do 5, A, B, C, and D. Go. Okay, the number one thing we need to talk about is corresponding points. Okay, if I'm going from P to P prime, which is over here, I go 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So 8 to the right, 2 down. Double check with another point. Q to Q prime, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So my rule should be that. 8 to the right, adding 8 to X, and 2 down. How did I know which one was which? My P, this is pre-image, is always first. My image is where I land. Okay, so keep that in mind as we're going. Now, what is the rule that describes the translation UVWXY to U prime, V prime, W prime, X prime, Y prime? Go from the solid image to the dotted image. Remember, corresponding points, check 2. Some people go, oh, I'm just going to check 1. Number one way to get it wrong, because you're just going to go from one point on the pre-image to another point on the image and they don't correspond. It's really nice when I do primes, but if I don't do primes, Mr. Bloom gets wicked with that. Get in the habit of checking 2, okay? Because really, seriously, all we're doing is counting, right? So hopefully you're able to check that in our image. I put it someplace here. Is X plus 4, Y minus 3? Are we doing okay? Am I doing okay? Did I write it down right when I was setting up this morning? Okay. Head bobbles are good. If you're not sure how this is happening, if this is like, boom, smoke, mirrors, take this show to Vegas. It's awesome. You just need somebody dancing up front. Okay? It'll be fine. Make sure that we understand what's happening today. Now, what's the rule that describes the translation A, B, C, D to A prime, B prime, C prime, D prime? So I'm going back from A, 1, 2, 3, down, 1, 2, 3, 4. So back in X is subtract, I'm going to the left. Down is subtract on Y, so that's what I'm doing. But I'm going to double check it. I'm going to check C. 1, 2, 3, 1, 2, 3, 4. Oh, thank goodness I got back to C. Okay? The translation of LMN to triangle L prime, M prime, N prime. Okay, find the coordinates of the pre-image. Uh-oh. Uh-oh. What do we do, Mike? Translation God. Yes, that's what we're going to do. We just switch them. Well, if you printed off directions from your house to your friend's house, you didn't print anything else off, and it said take a left, go here, go right, and if you are going to go home using the same directions because it was really confusing to get there, instead of starting at the top, because at the top you started from your house to their house, you'd start at the bottom and work your way back by doing the opposite of what it said. Well, we're going to do the opposite of what it said. So instead of subtracting 1 to the X, I'm going to add 1 to the X. Instead of adding 4 to the Y, I'm going to subtract 4 to that Y. So my very first one becomes that. And how I check? I just do the forward version of it. Okay? So go ahead and fill out the others. Remember, we are reversing the rule, okay, because we're trying to get back. We reverse the rule and try to get back. So I am taking, where did I put my little arrow cursor? Oh, I left it on the other page. Okay, I'm reversing the rule. I'm trying to get back. I take 1, I add 1, I get 2. I take negative 2, I add 4, I subtract 4, I get negative 6. 3, add 1 to get 4, negative 4, subtract 4 to get negative 8. 6, add 1 to 7, negative 2, subtract 4 to negative 6. And, it wouldn't kill us just to check to see if I did it right, because if I go the forward way, it should work, right? So just check it and make sure it works. Now, we're going to see how good we are at that. we have 3 at the bottom that are the same thing. A self-quiz on reversal. I know it says, you know, end of day 1, but I also am getting ready for the fact that we may have a shortened class period on Tuesday, and we can do little bits and pieces on Monday and cover those notes on Tuesday, no problem. Okay? So go ahead. Do that one at the bottom, right there. Go get it. Write the rule so that the A prime, B prime, C prime, D prime is going to A, B, C, D. I'm going to add on to that. After you finish doing these, I want you to write the reversed rule. Okay? The rule you used. I'll show you with the rule in A, hopefully, first, so you can see it. Write the reverse rule, okay? Because I might ask you that on a quiz or test, because that's a real simple question for me to check to see if you get going back from a image back to a pre-image. But the importance of that is that you understand the connection between pre-image and image, and then you can reverse it. And remember, we're just adding and subtracting right now with a purpose. And we're counting with a purpose, and we're plotting with a purpose. So those are really okay skills. So we just need to understand the vocabulary properties as we go through. You guys are doing great. Keep it up. Adding, subtracting fiends. Remember, just as a rewind, make sure we get it. I take -1, I subtract 1, I get -2. I take 2, I add 2, I get 4. I'm reversing because I'm at my destination and I'm going back. 5 minus 1 is 4. -1 plus 2 is 1. 2 minus 1 is 1. -4 plus 2 is -2. -3 minus 1 is -4. -1 plus 2 is 1. Okay? It's a vicious cycle. All right? My rule that I use to go from, and really what I should have said, to go from my images to my image to my pre-image is that. Okay? That's what I did. Whatever those were. Okay? That's what I did when I wrote my rule. Okay? Now, check B with a friend. And if you're done with C, check that too. Go. Say hi. You're doing okay with these, Max? Okay, and because I'm a purist, we will get that bottom part of the page and that because, you know, I want to start on the next page, not just go like have this little tidbit to finish up, okay? So, are you okay with these? And are you okay with our rules? And maybe I should go from primes back. In this particular case, I went from the primes. Ooh, I'm running crazy with my prime stuff. Let's pull that back up. Okay. Are you okay with that? Feeling good? Hey folks, I'm telling you, these rules, once you figure them out, it's pretty cool. But we have to keep together. Yeah, go ahead. We're just saying, what's the opposite of subtract? Oh no, I'm not adding. I'm just taking the opposite of subtract. So I'm adding. I'm taking the opposite of add. I'm subtracting. Yep. That's all I'm doing. That's all I'm doing. It's nothing really super fancy. Okay. So here, all I did, if I go back to the cycle, I take 7 plus 5 is 12. 2 minus 1 is 2. And that's all I'm doing. And I should be able to, after I get these values, double check myself by going forward. 12 minus 5, 7. 1 plus 1 is 2. 7 minus 5 is 2. 1 plus 1 is 2. 8 minus 5 is 3. 4 plus 1 is 5. 10 minus 5 is 5. And 4 plus 1 is 5. So it should work both ways. If it doesn't, ooh, I'm doing something creative, I should stop doing it. Okay? Are there any follow-up questions with it? Great questions, guys. Really, really great questions. Okay, so we're going on. to composition of transformations is a combination of two or more transformations in a composition. In a composition, perform the next transformation on the preceding transformation. So it's not, you don't go back to the beginning. You transform something, and then you go transform it again, and then transform it again, okay? I want you thinking like it's a clay project. You started throwing something on the wheel, okay? And now you're gonna put a handle on it because it's a mug. You've transformed the blob of clay, you made it kind of mug looking, and then you're gonna put a little handle on it. Those are two different transformations, okay? You don't go back to that blob of clay and just put the handle on the blob of clay, all right? So it is as you transform it, we're going back to the previous transformation, okay? And that's what a composition is. So a composition is any two translations is another translation, okay? And I get to add the X's and add the Y's, and we'll talk about that tomorrow. Or, you know, Monday, depending on what you guys want to do. Who wants to come to school on Saturday? Oh, okay, Monday it is? All right, cool, Monday. Thanks.